Welcome to an introduction to Python data structures. You can view these materials locally on GitHub or via slides. As we talk about data structures, one of the most useful things in my mind is to understand which data structures map to R and which don't. This is especially true if you're coming from an R background. Here, we'll specifically look at variables and lists as two different types of data structures that are common to both languages. They function slightly differently. And Python-only data structures of dictionaries and sets. We can think of variables as the types of objects that exist when we only have one value to store. That value can be a string, integer, float, boolean, at least in the common types. And there are a lot of different esoteric types of it. These are the ones that we'll be working with the majority of the time. Remember, as you assign these, under the covers, there are all objects. That means different objects have access to different types of methods. Some objects you can add, some objects you can't. When determining that, it really has to do with the underlying class type, and we'll get into a little bit of typing next. One of the most useful things you can do in looking at data and processing different variables is print that data out on the screen. Here we can see a variety of different ways that we've taken three types of data, string, integer, and a boolean value, and printed them out. We first separated them each by a column, then we added a column label. In the third option, we added tabs to separate them, and finally we added the new line character with this /n. These types of things can be useful as you're iterating between your data, processing that data, and putting it on the screen to be able to interpret it. Variable types are very important when we're understanding and processing data. One of the first things you'll do often in data munging is make sure that your data is being interpreted and imported in the correct type. In Python, when we write b equals 30, that means the value of 30 is assigned to the b object. Python is dynamically typed. Unlike a lot of languages, we don't actually have to declare the type of the variable before we're using it. And variables type can also change when we reassign that variable. Here in the example, we've assigned the variable first to integer type with number 1, then a float type with a number 2.5, and finally a string. In each case, the data is interpreted by the Python interpreter, or the code is interpreted by the Python interpreter, and doesn't cause a problem because A is not linked to the underlying type of the variable. It's the value that it has the specific type. So the variables, that's an important point. The variables themselves don't have the fixed type. It's the values that they are associated with that have the associated type. If we are working with variables of different types, we can get errors if we do things that are not appropriate. For example, trying to add 5 to a string. Here we get cannot convert integer object by trying to add 5 to the string variable. The type function is very useful in order to understand the type of a variable. Here we're passing the variable name to the type method and receiving as the output the specific type of the variable. Here again you can see an integer, string, float, and boolean each passed to the type function and what it returns. We can convert between types, and this is one of the important things that you'll do in data munging. Using the string command, we can convert from a integer type to a string. So here we have one that is a class string, We can have one that is a class float by converting it to a float. And then finally, we can convert it back to an integer and print out one, which is class integer. We can similarly convert Boolean numbers or Boolean values to and from strings, and also to Booleans. Within this example, here you have B, which is a string type, but with a value of true being converted to Boolean, which is a true-false value. In addition, we have an integer that can be treated as a Boolean. So here, 1 is being interpreted as a value of true for a Boolean value, and 0, that's a Boolean value of false. Missing values is also an extremely important area of data science, and understanding how different languages and even different data structures within those languages handle the missing values is very important. So, for example, within Python, the way variables handle the null value for a variable in Python is none. And when we go ahead and print out none, or a variable that has been assigned none, then it actually does print out none. But if we just list that variable, normally we would get the value of the variable, but here it doesn't print out anything. So that's the null variable in Python by default. If we're using a specific package, for instance, pandas is a very popular package we're going to be using for data frames, there's a different way of handling NA variables. We can also treat Python like a basic calculator, doing a variety of different operations from addition, subtraction, multiplication. Here, floor division, that we're returning the whole variable and discarding the fractional part, as well as returning the remainder. We can also do exponents. In addition, we can do a variety of operations on string variables. We may be looking to concatenate strings and work with characters that are interpreted by the Python interpreter in a special way. For example, the apostrophe can also be considered a quote. And when we're indicating a word like can't, as in this value C, we need to specify that this is an apostrophe. And we do that with the backslash. A backslash apostrophe indicates to the Python interpreter that it should not consider the next value a quote. In other cases, we may want to work on multiple long lines when working with long string fields. In this case, with continue line, we see that this is the first line, has embedded within this continue line character. It'll ignore all the white space to the right of that line. And continue, this is the second line, but we have included the continue line character. If we want to actually print out the continue line character, we have to tell Python to not interpret it as a continue line character or as a string, and so in that case we include 2. So you can see we have printed out down below can't with an apostrophe in it, and that apostrophe obviously wasn't interpreted as a quote. In addition, we have a continue line indicator where this is the first line and this is the second line. Even though they're on 2 lines up here, because of the continue line, it gets interpreted as a single line. Those are just some basic operations on string. There are a lot of built-in functions via Python that you can call. For example, absolute ABS takes the absolute value of a variable. Round, we'll be able to round it to the nearest integer. character 98 returns a string representing or with the Unicode code pointing to the actual value of that integer. So for example, character 98 refers to an integer b. I've provided a link with a variety of these different built-in Python functions, and you can view those and see just the types of wide variety of things that you can do that are embedded within the core of Python. So now let's go a short exercise in which you attempt to do a few different things within Python variables and see what happens. So first, what happens when you multiply a number times a Boolean? What's the resulting type? For this one, you should make sure that you understand what the resulting type is when it's true and what is when it's false. Second, what happens when you try to multiply an integer value times a null? Is that an operation that's allowed? Finally, take 5 to the power of 4 using an embedded function. So not the calculator function that we saw, but one of the functions that we linked to in the above slide. Take some time to do that now, and we'll see you in a little bit.